friends, my name is Amita and in this video I am going to discuss about the DC circuit transient analysis for a series RC circuit using Laplace transform. Before going into detail of this DC circuit transient analysis, first you should understand that what is the difference between the steady state analysis and a transient analysis. Dear friends, you know that when the circuit is fed by DC source, it will be called as a DC circuit, and if the circuit is fed by AC source, it will be called as an AC circuit. Now, as the topic of this video is of DC circuit analysis, so DC circuit analysis can be of two types: steady state analysis and transient analysis. When the DC source is directly connected to any of a passive element, then that kind of analysis is called as a steady state analysis because the DC is constant in nature, so there will be no change in the circuit happens, and that kind of analysis is called steady state analysis. When we are doing the DC circuit steady state analysis, there is no uses of connected inductance or a capacitance, because inductance supposes the change of voltage and inductance supposes the change of current and capacitor supposes the change of voltage. In case of DC source, both did not happen, so there is no use of connecting inductance and capacitance when we talk about in DC circuit steady state analysis. That's why only the resistive circuits are there when we talk about DC circuit steady state analysis. But when the DC source is connected to a passive elements, whether it is a resistance, inductance or capacitance or a series or parallel combination of these elements, then with the help of, due to the switching, there is a change in the voltage applied to these elements happens, and there will be a role of inductance and capacitance will also comes into picture. So as the topic of this video is DC circuit transient analysis for a series RC circuit using Laplace transform. So now without wasting time, my dear friends, I am sharing my screen where I will brief you the DC circuit transient analysis for a series RC circuit. So let us talk about DC circuit transient analysis. This is for series RC circuit using Laplace transform. So let's see the circuit. This is a switch and there is a resistance R and there is a capacitance. Vs is the DC supply voltage, R is the resistance, C is the capacitance, Vs DC supply voltage, S is the switch. Switch S is closed at t is equal to 0. So there will be an current starts flowing, that is IT. So what will be the KBL equation? Now if I write the KBL equation, that will be Vs is equal to RIT and the voltage across capacitor is 1 by C integration IT dt. Now take Laplace transform. Now if I take the Laplace transform, the constant Laplace is Vs by S, IT का Laplace is Is and integration का Laplace is 1 by C Is by S minus Vc 0 minus. Now Vc 0 minus is nothing but it is the voltage across capacitor at 0 minus. So before t is equal to 0, the switch S was open, so there was no supply connected to capacitor. So what is the value of Vc 0 minus? That is 0. So as before t is equal to 0, switch was open, hence no supply was connected to capacitor. So Vc 0 minus is 0. So when I put this value, what I am going to get? Vs by S, that is equal to Ris plus 1 by C Is by S. Now if I take Is common, what I am going to get? If I take Is common, Is R plus 1 by Cs. Now Is is equal to Vs by S R plus 1 by Cs. This I can write it as Vs upon S RCS plus 1 upon Cs. S से S cancel. VSC RCS plus 1. This I can write it as VSC RC I can take common. S plus 1 by RC. C से C cancel. I'm going to get Vs by R S plus 1 by RC. Now this is Is. I am interested to calculate the IT. So take inverse Laplace. So if I take the inverse Laplace, what is the inverse Laplace of Is? That is Ia. So that is IT. That is equal to Vs by R, and 1 upon S plus RC का inverse Laplace is e की power minus t by RC. Similarly, if I want to calculate VCT, that is 1 by C integration 0 to t I t dt. So 1 by C integration 0 to t Vs by R e की power minus t by RC dt. So what I am going to get? Vs by RC e की power minus t by RC divided by minus 1 by RC limits from 0 to t. So RC से RC cancel. What I am going to get? Minus Vs e की power minus t by RC limits from 0 to t. Now put the limit minus Vs e की power minus t by RC minus e की power 0. So what I am going to get? Minus Vs e की power minus t by RC e की power 0 is 1. So 1. So this I can further write as Vs 1 minus e की power minus t by RC. So finally IT I got Vs by R e की power minus t by RC, and the voltage across capacitor I got Vs 1 minus e की power minus t by RC. Now if I plot these two waveforms, this is t, this is t. If I plot here IT, if I plot here VCT, if t is equal to 0, e की power 0, that is 1, that means Vs by R. If t is equal to infinite, e की power infinite is 0, so Vs by R, and somewhere at infinite it will be 0. Similarly, if I put t is equal to 0, e की power 0, 1, 1 minus 1 is 0. So voltage across capacitor at t is equal to 0, 0. E की power infinite, e की power t is equal to infinite. So e की power minus infinite is 0. So it will be exponentially increasing up to Vs. So you can see that the current is exponentially decaying, and somewhere at infinite it will be 0. And voltage across capacitor is exponentially increasing, and in between it is vary by expression of minus t by RC. Similarly, in between it is varying by expression of Vs by R e की power minus t by RC. So this is something about the current through capacitor and the voltage across capacitor. Now the next thing is time constant of RC circuit. So the first thing is, it is the time taken by the circuit in which the current reduces its value from Vs by R, that is a steady state value, to 36.4% of steady state value. Or it is the time taken by the circuit in which the voltage across capacitor increases its value from 0 to 63.6% of rated voltage, that is Vs. Now one more thing I want to tell you, that as you know the expression of current is this, expression of voltage across capacitor is this. Time constant is represented by TOA, and this is equal to RC for a series RC circuit. So we know that the expression of current is Vs by R e की power minus t by RC. So this I can write Vs by R e की power minus t by TOA. Similarly, VCT I can write, as we know, that is Vs 1 minus e की power minus t by RC This I can write Vs1 minus e to the power minus t by 2e. So this is nothing but time constant of a series RC circuit. So that's it. Now I'm stop sharing my screen. Now my dear friends, whatever information I have shared in this video related to a DC circuit transient analysis for a series RC circuit, now it will be clear to you. I hope now you understood the difference between steady state and transient analysis. As you have seen when we were doing the derivation, we have calculated that the current is exponentially decaying in case of capacitor, RC circuit, series RC circuit, and the voltage exponentially increasing. We understood what is the meaning of a time constant. That is mathematically it expressed by an multiplication of resistance and capacitance. Means if you want to increase the time constant of a series RC circuit, that time taken to reach the specified value of a voltage will be more. So my dear friends, I hope you like this video, and if you also feel the same, kindly press the like button. And if you feel that whenever I make such kind of videos related to network analysis, then please subscribe my channel. One more thing I want to tell you, that if you want to see the DC circuit transient analysis for a RL circuit, then please watch my video. The detail of that video I have given in the description. And if you want to learn the series RLC circuit, DC circuit transient analysis, then keep watching my videos. I'm going to make my next video on series RLC circuit transient analysis. Thank you.